there's a function y equals x squared. If I want to calculate the area under the curve from 0 to 8, I will draw rectangles under the curve and add up all the areas. First of all, I will look into left endpoint. This rectangle doesn't have height, so the area will be 0. And this rectangle, the length is 2, so 2 times the height is 4. This is 2, the height is 16. This height is 36. So this is the lower sum because I used left endpoint, which means I used left x value for this rectangle. So the height was 0 here, and for this rectangle I used left endpoint, which was x equals 2, and the height was 4 at x equals 2. So likewise, at x equals 4, the height was 16. So if I use left endpoint, this empty area because of this empty area, the sums of all the rectangles will be less than the actual value. What if I use right endpoint? If I use the right endpoint, for example, I will begin at x equals 8. So for this rectangle, if I use the right endpoint, the height will be 64. So 2 times 64 plus for this rectangle, if I use the right endpoint, the height will be 36 for this rectangle plus 4. If I add up all this, it might be 140. So this value will be over the actual area under the curve because these areas will be over the actual area under the curve. So if I average these two endpoints, This will be 176. Mm, If I calculate the actual area under the curve from 0 to 8, definite integral from 0 to 8 x squared dx. So antiderivative of x squared is x cubed over 3 from 0 to 8. So this will be 8 cubed. So this will be so the actual area and the average of the two endpoints is similar. What if what if I divide the rectangles? What if I create a lot of rectangles to infinity? That might be that might be very near to this the real area.